This video has three parts. Part 1, 2, 3. Part 1 is this math problem. We will solve this one. Part 2, we will solve a problem from USACO Silver Part First Contest, December 2023. We will consider ideas, important ideas. It's good for preparing for USACO 2023, 2024, and so on. And in part 3, I leave homework. You can try, you can solve that, and you can comment your answers right below this video. And you can use the chapters in my video time codes to go straight forward to the part you want. Okay, let's try problem of first part. ABC. ABC are integers such that a plus b plus c 12 and abc is 60. We want to find all possible values of ABC. So we should start from which equation? It is so much important. Sometimes it's important to start from the right equation. We can start from this one. We can use replacement, or we can use this one. And because ABC are integers, we can say ABC should be a divisor of 60, which will be plus minus 1. And let me tell you, if you want to find all cases, if you prime factorize, it's 2 squared times 3 times 5. And one thing, if you want to find number of divisors, you say, okay, two cases for plus or minus. 2 to the 0, power of 2 can be 2 to the 0, 2 to the 1, 2 squared 3, and 3 to the 0, 3 to the 1, 2, 5 to the 0, 5 to the 1, 2. So it will be 2 times 3, 6, times 2, 12, times 2, 24. So it has 24 divisors. Okay, here number of divisors, you can generalize it. 2 times product of, you should add 1 to each power and multiply them together. So we should write 24 divisors. So we should write 12 numbers plus plus minus. So next one is plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, 7. We don't have 8, 9, 10, plus minus 10. Okay, now it's 60, like rainbow idea. You can write other numbers. Let me put here. Okay, plus minus 10, plus minus 5 times 12, 4 times 15, 3 times 20, 2 times 30, and 1 times 60. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can check what? We can check, for example, A. A is plus minus 1. So if A is 1, then B plus C is 11. And BC is what? BC is 60. So because some of them is 11, one of them is odd, one of them is even. Without loss of generality, it is odd, it is even. And the even should be multiple of 4. Okay, so C should be plus minus 4, or plus minus multiples of 4, 12, plus minus 20, plus minus 60. And here when it's plus minus 4, this one plus minus 15 for B, plus minus 5, plus minus 3, plus minus 1. So we should see, do we have any case that B plus C equals 11? 15 minus 4, but both of them should have same sign because the product is positive. So here we cannot say 15. 15 plus 4, 19, 15 negative 15 minus is negative 19. This one plus minus 17, this one plus minus 23, this one plus minus 61. So A1 is not possible. Now if A is negative 1, if A is negative 1, B plus C is what is negative 1, you consider here. If it is negative 1, you can add 1 to both sides. B plus C will be 13. BC is negative 60. Okay, again, you can say one of them even, one of them odd without loss of generality. Odd even, so this even should be multiple of 4 again. Here plus minus 4, plus minus 12, plus minus 20, plus minus 60, but because the product is negative, this one will be negative for positive, for negative 15, for minus 4, plus 15, minus plus 5, minus plus 3, minus plus 1. So here negative 15 plus 4 is what? Negative 11. Plus minus 11 doesn't work. 12 minus 5 plus minus 7. 20 plus minus 17 plus minus 59. So A1 negative 1, they don't work. So now we can remove this divisor. Next one, we check A plus minus 2. If A is plus 2, B plus C plus 2 is 12. So B plus C is 10. And BC is what? 60 over 2, 30. Here, we can say again one of them even, one of them odd. Both of them, sum of them equals 10. And so both of them even or both of them odd. If both of them be even, then product will be multiple of 4. Okay, so then 4 should divide 30, or 30 is multiple of 4. It's not possible. If both of them are odd, the product will be odd. Contradiction. For a negative 2, you can say same thing. Okay, so we can remove negative plus minus 2. Now let's check 3. If A is 3, B plus C plus 3 is 12. So B plus C is 9. And BC is what? ABC is 60. So BC is 60 over 3, 20. So one of them even, one of them odd. We can say without loss of generality, this one even, this one odd. So because this one is even, this one is plus minus 4. So plus minus 5. And 4 times 5 plus minus 20 plus minus 1. So in this case, B plus C, we want to reach 9, so it works 5, 4. So you say 3, 5, 4. Negative, both of them should be negative or positive. If both of them be negative, B plus C will be negative. Why both of them should be negative or positive? Because BC, the product, is positive. If both of them be negative, for B plus C, we have problems, so both of them should be positive. So we have this, and you can consider all permutations of this. 3, 4, 5 for ABC. 4, 3, 5, and so on. 3 factorial permutations for this. You can continue. So as homework, comment other answers right below this video. Okay, so it was part 1. It was a casework problem. Okay, idea 2, we can say it was a casework problem. Now, let's try this part in part 2. Let's try this USACO problem. Read the problem first completely. It is a game problem. Let me tell you, we have 4 ideas in game strategies problem, and we will use 1 or 2 of them. 90% of the problems can be solved with one of these 2 things. Here, Farmer John, and his next one is Farmer John in reverse order. And if you read the problem, it is second player, first player, this one, second player. And let me explain the game in the example here. One way is to read input output first, then read the problem to understand it better. It says 5 test case. We have 5 test cases, and we have 1 room. And it has 4. What? Let's see each of them. A circular barn and rooms. The barn, the ith room initially contains AI cows. Okay, so here we have, for example, 4 cows. And then it says in each step, each of them, for example, first player plays, then second player, then again first player and second player. And in each step, they can take 1 or a prime number. The player that cannot play is loser. Okay, so here, first player can take 1 to reach 3, or 2 to reach 2, or 1 to reach 1. Then for all cases, second player can reach 0, minus 3, minus 2, 2 is prime, 3 prime, and 1, because he can take 1, 0. So In both cases, second player can finish the cows here. Then when first player want to play a game, then he cannot do anything. Why? Because there is 0 cow here. So for this one, which player is winner? Second player. So farmer, this, not. John in reverse order. I've explained this one. Second player is winner. For next one, 1, 9. So for 9, first player can go to 4. Okay, and it is a lemma I will explain for you. Why? Because winner of 4 is second player. Here we proved. So when 9 goes to 4, it's good for first player. Why? Because then 4, second player can go to 3, 2, 1. Then when first player plays again, he can reach 0. Okay, so for 9, it will be first player. Well, so this one was related to first test case, second test case, third test case. 2, 2, 3. Here we have 2 rooms. So here look, it says we have n rooms in the bar. And turn over. Okay, so here it is what? 2 and 3. We want to see which of them is winning. So for this one, first player reaches 0 here. Then second player cannot play, so first player is winning. Okay, as easy as this. Next one, 2, 7, 10. Again, we can do the same. 7, 10. First player can reach 0, then second player cannot do anything. So again, Farmer John, first player is winner. This one, 3, 4, 4, 9, 4. Let me explain this one more, 4, 9, 4, to see what happens. For 4, second for 4, second player is winner. When second player can reach 0 in 2 steps. For 9, first player is winner. Here we proved 9 can go to 4. So first player should reach to a case that. So let me explain for you. First player is winner, so first player can take 1 or 2, or I will reject 7, or 3, or 5. I want to write all possible cases. 9 minus 5, 9 minus 7, 2. Okay. In this case, here, first player plays 7 is bad, because then second player will be winner. 2 is also bad, second player is winner. For 6 also it's bad. The second player goes to 4, takes 2, and then from here, second player is winner. So first player won't choose these 3 things. Because in these 3 things, second player can win. 8 or 4. For 4, the first player take any number of, for example, cows, then first player can reach 0. So for this one also, we can say in at least first player can guarantee to reach 0 in at least 3 steps. Okay, so in this one, first player is winner. In this one, second player is winner. In this one, second player. These lengths also are important. So for this one, I will prove why for 8 also second player is winner, so first player is good to move this part. But for 4, we can guarantee that in 3 steps, first player can reach 0. For this one, first, when they are in this room, it will reach to 0. And here is x. Then after applying this room, x, then 0. Then when they reach here, first player cannot take anything, so second player is winner. As you can see here, second player is. For this problem, I told you how many ideas? 2 ideas. For this problem, first we should try small examples. Okay, so much useful in USAMA, USACO. Let's see here, it means what? Suppose we have one room. We want to see who is winner. So, and we consider one room. So in that room, suppose we have A1 cows, and we want to see who is winner and minimum length to reach 0. Means minimum number of steps. Here, look, in length is 2 to reach 0, here 3, here 2. That they can guarantee. So A1 is 1, 2, 3, 4. Let's focus first on which of them is winner, then 5. Okay, so try to fill up to, let me tell you, 6, 7, 8, for example, 9, 10, 11, 12. Try to find who is winner for these 12 numbers. Try first pause the video and try first on your own. So if A1 is 1, first player is winner, obviously, because you can take 1 or a prime number. 2 and 3, one can take all of them, then 1 is winner. The player that cannot take anything is loser. So for 4, from 4 you can go to these things, and then second player will win. So 4 is 2. Let me generalize this idea. It's so much important. It will be idea 4. It is an idea in game strategies problem. For example, suppose we are in position 1. We can go to these K positions. Now W, winner of position Y, is 1 if one of them is 2. If there exists, this sign means there exists xi such that wxi is 2. Otherwise, it's 1, 2. Let me explain here. Look, for example, here, when you go to this part, this part, this part, all of them are 1. It will be here. So in all cases, first player will be loser, so second player is winner. For 5, you can take 1 and go here. So because f of this is 2, w of this is 2, so first player is winner here. 6 to this, first player is winner. 7 to this, take 3. Is winner, but for 8. If 8 want to be a winner, then we cannot take 8. Also, it cannot go to this one, because you should take 4. 4 is not prime and it's not 1. So in this case, we will have this part, that all of them equals 1. If you go to any of these things, or for example, also 8 minus 5, 8 minus 7, all of them equal to 1. So this one again will be 2. For 9, you can go to this one. For 10, you can go to 8, take 2. For 11, you can take 3. For 12, again, you cannot go to this one because you should take 4 or you should take 8. You cannot go to these two things. You cannot take all of them because 12 is not prime and it's not 1, so it's 2. So we can understand that in this case, winner of 4k is equal to 2. Also, we can add 0. For 0, we can say 2 because first player cannot take anything. So, for example, like 7, you can also go here. Okay? Now, minimum length is what? For this part, let's check. For 1, minimum, for 0, minimum length is 0. For 1, minimum length is 1. Let me move it here. For 2, minimum length again is 1. In one step, we can reach 0. For 3, 1. For 4, second player can reach to 0 in 2 steps because first player, it's not important. First player takes how many cows? Second player reaches 0. So it will be 2 steps. Now try to find other minimum lengths for 5 to 12. Try to find them. Okay, for 5 can go to 0 in one step, first player. 6, you can take 5 Sorry. For 6, because we want to first player is winner. First player won't take 5 to reach 1, because then second player is winner. 6 player can go here or here. First player. 6 is not possible because 6 is not prime, but 2 is possible. 2 is prime. So 2 steps here, length, and plus 1 step here, so it will be 3. For 7, first player is winner, 7 is prime, so we can reach here, and it's 1. For 8, because second player is winner, first player wants to do something that second player reach 0 the maximum number of steps. So if from 8 it goes to 6, then second player needs 3 steps at least. 3 plus 1, 4. Okay? And why minimum length is important? Because when we have more rooms, then the player, for example, if second player here wins, if second player want to reach in smallest number of steps to 0, but for example, if second player is winner, but first player doesn't want. Okay, so we have this logic. Now let's continue like this. For 9, now 9. First player is winner, so first player should go to one of these things. Like here. So the first best one is this one, but we cannot take 9. For this one, 9 minus 4, 5. This one is good. So 2 steps plus 1, 3 steps. Okay. So we found maximum prime to reach a 4k, multiple of 4. For 10, first, because it is even number, when we want to reach the case that f is 2, 4k, the only possible case is taking 2 to reach 8. So 4 plus 1, 5. For 11, in one step, first player can win. For this one, first player goes to a case that is worse for second, because second player is winner. So first player takes 2. The maximum number here is 5. So 5 plus 1, 6. Now we can guess something by considering these numbers. W of, for example, A1 is what? Or any AI. If A1 is 4K, like 4, 2, 8, 4, can you guess it's what? It's 2K. If A1 is 4K plus 2, like 2, like 6 is 3, 2 is 1, over 2, and 10 is 5. If you divide by 2, 2K plus 1, and for other cases, we want to prove something. It is what? When A1 is, for example, 4K plus 1, like 9, or like 5, we want to we can prove by these things that we want to reach what, for example, when we are in 9, we should reach to one multiple of 4, okay? This one. And we want to have minimum length. First player is winner. And first player should go to a multiple of 4 because W is 2 in those cases. And we know they are increasing because of this, if we prove this one first. Then we say what? We should find, because they are increasing, we should find the maximum prime, that if you subtract from 9, it will be 4k. If you subtract a prime from 9 and it is 4k, so that prime is what? Mod 4 if you consider. That prime is 1. So you should consider W of A1 minus P. Let's consider, for example, P1, that P1 is prime. And maximum prime, that P1 mod 4 is 1. And P1 is less than or equal A1. Okay, so we have this condition. Let me copy this one and paste it in another place. This is our claim. So This one, this, P1 should be this, and P1 should be less than or equal to this. If A1 is 4K plus 3, again, first player is winner. Like what? For example, 4K plus 3, 11 is prime, 7 also is prime. Let's continue this one. We know for 13, 14, 15. First player is winner, first player is winner for 13. In one step, first player can reach 0 for 14. It should go to only this one. Length is 7. And for 15. For 15, maximum prime, that is less than or equal 15 is what? We should reach multiple of 4. Minus 15 not possible. To reach 4, it is 11, okay? So 15 minus 11 reaches this part. Here 2, so it will be 3. First player is winning. So in this part, again, you should find a P1. Here, for example, a prime P. Let's consider here P2 or something like that. We can say P. P is prime, P, P. In this case, P mod 4 is 3. Again, maximum prime, that P is less than or equal to 1. And this one is this length plus 1. Okay, because you should take P in one step and then the others. This one also W of A1 minus P plus 1. And we will reach maximum prime. So for this number, let me explain for you why I want to prove these two things for you first. Let's see to prove by induction or not. For example, suppose A1 is 4K, 4K plus 1, 4K plus 2, 4K plus 3, 4K plus 4, 4K plus 5, 4K plus 6. And suppose we know that winner here is 2, here 1, 1, 1, here again 2, 1, 1, and minimum length. Okay. So suppose, for example, by induction, this one is 2K. For all other previous ones, we have something like this. Now for 4K plus 2, we know it can take only 2 because first player is winner and the only possible case is to take 2 because if you want to reach other multiples of 4 because W of them is 2, W when it is 1, you should go to something that W is 2 by this idea that I explained, idea 4. So other numbers are not prime, but the only prime is 2, so you should take 2 to reach this part. And so 1 step plus this one, 2K plus 1. So by considering this one, I proved this, okay? Now for 4K plus 4, we know second player is winner. And if you consider all these numbers, okay, first player knows that in this case, he will lose, so it wants only to maximize the length of steps. Between them, you can prove by induction again. The maximum one is 2K plus 1. You can add this, and it takes 2 here. And look, first player doesn't want to win because we proved second player is winner. Only maximize the length of step. So if it takes 2, 2K plus 1 plus 1, 2K plus 2. So we proved also this one by considering this. Again, you can consider 4K plus 6 by applying this one. Now, for 4K plus 1, we know first player is winner, so it should reach a multiple of 4. That is the smallest, okay? And we know the multiples of 4 are in increasing order, so we should find maximum prime. For 4K plus 3 also, we should do the same thing. The maximum prime, that when you subtract, it will be multiple of 4. First player is winner. And because the numbers in multiples of 4 are increasing, W length of them is 2K when it is 4K. A1 is 4K, minimum length is 2K. So we should find maximum prime. So for this problem, we need prime's number. Okay, up to which number? AIs are less than 5 times 10 to the 6. Okay, let me add a page. Okay, 1 AI 5 times 10 to the 6. For the case that it is 4K plus 1 or 4K plus 3, we need to find maximum prime. So we want to find prime numbers less than or equal to this. How we can do this? In the beginning of the solution, you can check numbers. For example, you can say, okay, 4 from I1 to N. And you can, for example, have an array, the name is prime. Then you check, you add primes here. Suppose, for example, size of prime is 0 first. Then you say what? For each number, you say, okay, for j equals, suppose there are 1 base. 1, 2, well, let's consider 0 base here. 0 to less than size p. Both of them are okay. Let me write with 1 base. If, you should check, if, for example, prime, if I mod uh, prime of j is 0, then I is not prime, okay? Then I is not prime, you should break and continue next numbers, okay? And you need to only check up to which primes? Up to square root of j. J is from 1 to this, and also you should pay attention that prime of I should be less than or equal square root of I. It is a theorem in number theory. The idea is what? Idea 5. If n is a composite number, means if it is not prime, then it has a prime factor less than or equal root n. The reason is what? Because if it is composite, you can write it as AB, which A and B are greater than 1. Now, without loss of generality, suppose A is less than or equal B. So we can say what? It is greater than equal A times A. Instead of B, we write A squared. So A is less than or equal root. If A is prime, so we've proved the problem. If A is not prime, A is greater than 1. Then there exists a P that divides A. So P is less than or equal A, and P is less than or equal root. So we need to only check this for our time. It's important. So let me explain for you how we can fill this array. We start from and because when you want to check I, the primes start from 2. So for 2, we don't have anything in prime, so we don't have any zeros. So we add 2 in this array. Then for 3, we check 3, and this one is not less than or equal root 3. We don't check this, and we add 3. It's okay. Now let's check 4. For 4, square root of that is 2. We check up to that number. 4 is multiple of 2, so we don't add 4. Next one, 5. Square root of that is 2. We check this one. 5 is not multiple of 2, so we add 5. And like this, we have these all primes up to 1 to 5 times 10 to the 6. And then so we can, because we find these primes, so we can fill minimum length for all these numbers. Okay, because when you are checking these numbers for AI, let me tell you, for each of the minimum length we will find for AIs. Okay, it is prime, and then we will find minimum length for these numbers in the beginning of the solution. You check again from 1 to 2 times 10 to the, was 2 times 10 to the 6, I think. 1 to 5 times 10 to the 6. So on, and this number you should check 5 times 10 to the 6. Okay, for this one also, for this one we should check up to 5 times 10 to the 6 for each of them minimum length. For 0 minimum length is 0, for 1 minimum length is 1. And like this, when you reach something and you want to find, for example, maximum prime, always when you continue these numbers, you should also move, you should have a pointer on this, and always you should update maximum prime, that is 1 mod 4k plus 3, maximum prime that has 3 mod 4k plus 3. When you consider like this, you should move this pointer. If, for example, here we reach a greater number, for example, you reach 11, you should move this one 7, and these things, and update maximum p1, p3. So when you reach a number, you know maximum p1, p3 is what, and you can find minimum length. Okay? Now, I will show you also the code. So we will fill these two arrays, minimum length and AI now. Last step. We have some numbers. These numbers are what? For example, it is 10, it is 5, it is 4, it is 3. So in each of them, for example, I know one in one step first player can win. This one is first player, this one is first player, this one second player, this one again first player. Make correct this first player, first player. And we know number of steps. For example, 10 length of step of 10 was what? Here we checked 5. Okay. So 10, 1, 2, 3, 4, 5 first player. This one with one way, one step, two step, one step. And for example, 7 in one step. Okay, or 12. 12 is what? Is 6, I think, 6 steps. Yes. And the minimum length is 6. 1, 2, 3, 4, 5, 6. Now we want to see so obviously here first player will be winner because when they reach 5, then reach this first player reach 0. But I want to find a general way. I want to see in which round they will reach 0. Okay, so this one, for example, 10, 1, 2, 3, 4, 5. This is in first round. This is in first round. So in third round. Okay, this one in first round. This one again in first round. What second player wins? This one first round, first player wins. This one in which round? First round. This one first, second, third. In third round, it reaches 0. Now I want to see in which round the player wins. This one was round to reach 0. Now we want to see round for winning. In which round? Round to win. Here in third step, first player will reach 0, and in third round, first player wins. This one in first round. This one, second player in first round reaches 0, but in second round, second player wins because in second round, first player cannot win. So you write second, this one first, and this one. In fourth round, second player wins because in third round they reach 0. In fourth round, first player cannot play. Okay, so now we have these numbers. Okay, so let's call this one R, big R, R to W. Now that we have these numbers, let me tell you with minimum length how we can calculate. Suppose minimum length is ML. So R to W of, for example, I is what? Suppose this one is, for example, ML of I, minimum length. If minimum length of I is even, then means second player wins. Like what? Like this one that here we have 6. Then which round is the round to win? Minimum length of I over 2 plus. If ML of I is odd, like 1, in which round they win? For example, if it is 3, in first round, in second round, they win. So it will be what? ML of I plus 1 over 2. Okay, so we calculate this now. We know in which round who wins. So you should find minimum in R to W in this array. For example, 1, 1. You should find minimum. Suppose this one is minimum M1. If we consider these values, so suppose for example we have R1, R2, R3 to Rn. Some of them are minimum. We find all these minimums. For example, R3. And now we know, for example, in this round, one of them wins. In this round, one of them wins. So we should find first one in these minimums. W is what? Winner is what? Winner is 1 or 2? I mean, no, winner is 2 if it is 4K, if winner is 1, if it is not 4K. Then if W is 1, first player wins the first minimum. If W is 1, first player wins. If W is 2, second player wins. Okay, so I've explained compute. Okay, the code is this. And all these things. If you have any question or want to learn more things, as I said before, feel free to send message to my WhatsApp number in the description. Now let me tell you homework part 3. Try to solve this problem. A plus B plus C is 15. ABC is 120. In this case, suppose that ABC are positive integers. Then how many answers? How many ABC are? So solve this problem and comment your answers right below this video. And as I said before, if you want to learn other important ideas, feel free to send message, especially for some in-game strategies and other things useful for USACO, USAMO, AMC, AME, other math exams. Feel free to send message to my WhatsApp number in the description. Okay, thanks for watching this video. Have a good day. Bye.